right, good morning. What I'm going to be doing now is going over a handful of questions from the study guide. So you spent the last class period working on this on your own. I'm just going to go ahead and go over a smattering of questions and then let you continue working on the study guide. So first page is over properties of logarithms. So remember, we can translate multiplication into an addition, additive property with logarithms. Division will translate into subtraction. So ln of 12, well, 12 is the same thing as 3 times 4. So I can expand it like that. Remember, addition of logarithms translates to multiplication on the inside. And then I can rewrite 4 as 2 squared. And remember, we can always bring an exponent outside. So I can write it as that. Remember, because you can take the power, pull it out front as a coefficient, as we see with this property here. So I can always take the exponent and pull it out front as a coefficient. Like that. Remember here, subtraction translates into division. So your positive logarithms give you numerator factors, negative logarithms give you denominator factors. So I can write that as log of A over B. Now let's practice going in the opposite direction. So here, log base 2 of a bunch of multiplication, which will translate into addition. So that means log base 2 of U plus log base 2 of V plus, and then remember I can pull the exponent in front as a coefficient, plus 3 log base 2 of W. So again, just straightforward applications of the properties of logarithms. Now here, I can take that exponent and pull it out front as a coefficient, or I can simplify the interior. Either one will work. I'm going to go ahead and simplify the interior. So that's u cubed to the third power. Remember, when you have an exponent raised to an exponent, assume there's no addition or anything on the inside, you just multiply the powers. So that'd be u to the 9th v cubed. I can then expand that. So that'd be 9 log base 9 of u plus 3 log base 9 of v. If you pulled the 3 out front at first and then expanded, you'll get the same result. Either way is fine. Let's look at combining logarithms. Since they're both base 9 logarithms, I can combine them into a single log base 9. Notice there's subtraction, so I'm going to have a numerator and denominator. Remember, in class before spring break, I told you that the positive logarithms are your numerator factors, negative logarithms are your denominator factors. That was when I was using the different colors in class to demonstrate that. So it's going to be u to the 5th in the numerator, v squared in the denominator. Notice here there is no subtraction, so there will be no division inside the logarithm. This is going to be straight multiplication. So it's w to the 4th power, and then times u to the 1/3. There you have it. So there's a recap, and then all the other problems are very similar. The only comment I have on the last one is don't forget your properties of exponents. A rational exponent represents a radical. So I can rewrite that 1/3 exponent as a cube root. So don't forget your properties of exponents. Moving right along. So here, we're going to go ahead and solve some equations and round if needed. Now, these first 4 questions are all powers of each other. So 243 and 27 are powers of 3. 16 and 24 are powers of, 16 and 64 are powers of 4. 25 and 625 are powers of 5. 32 and 4 are powers of 2. So the first 4 problems are all very similar. So 243, for example, I know 3, where's my exponent button? 3 to the 5th power equals 243. So what that means is I could take 243 and rewrite it as 3 to the 5th. And then 27 is 3 to the 3rd power. Just like that. So remember, I just mentioned this a few moments ago. Whenever you have an exponent raised to an exponent, you multiply the powers. So it's going to be 3 raised to the negative 15n. Really didn't need that parentheses there. 3 to the negative 15n equals 3 raised to the 3 times 2n minus 1. Since exponential functions are 1 to 1, the only way this could be a true statement is if these exponents equal each other. Really not much room on this paper. I'll switch to loose leaf paper. So set those equal to each other and solve. So that power has to equal that power. So negative 15n would have to equal 6n minus 3. Subtract the 6 over, so negative 21n equals negative 3. Therefore, n would equal 1 over 7 when you divide and reduce the fraction. 17 is very, very similar, as is 16, 17, and 18. They're all very, very similar. So remember, 1 over 25, I can write that as 5 raised to the negative 2. Go ahead, I'm going to switch to loose leaf paper here where I have a little more space. We'll take a look at 19 next. So there's 19. Now, unfortunately, we don't have any clever exponent tricks we can do here. Right. There's no powers of 18. So first thing you want to do is actually isolate that exponential. I'm going to go ahead and isolate that 18 to the negative 4n. So divide both sides by negative 2, which will give me, see here, 53 divided by 2, which would be 26.5. And notice, again, there's no clever exponents, right? 26.5 and 18 have no really common, or any common powers of anything. So what I'll need to do is log both sides. So natural log the left, natural log the right. The whole reason we natural log each side is that lets us pull the power out front as a coefficient, just like we were doing on the first page. I'll go ahead and start writing my natural logs in cursive so they're a little easier to identify. All right. And then all I have to do now is divide. So I got negative 4 times n times natural log of 18, so just divide to cancel out all that multiplication. What you do to one side, you have to do to the other side. We're going to type that into the calculator. We have natural log of 26.5 divided by the quantity. Notice I got to put my denominator in parentheses, so I'm dividing by the entire quantity. Negative 4 times natural log of 18. Close it off. Send it, and there's our answer. And it said round to the nearest thousandth. So the nearest thousandth is going to be the 3rd decimal place. I'm going to round this to 3 decimal places. And there's my approximate solution, as you can see there. All right. So that problem 19 is going to be very, very similar to 20. Add the 10 over, log both sides. Here, subtract the 1, divide by -10, log both sides. Here, isolate and log both sides. So these 4 questions are all very, very similar. So I want to go ahead and take a look at 23 through 26. So 23 through 26 are all quite similar, and that you're going to use the one-to-one property of logarithms. It basically states if I can get logarithm equal to logarithm, the inputs have to be equal. So for example, for 23, in order for this to be a true statement, 3n plus 10 has to equal -4n minus 4. Those have to be equivalent. 24, you can just add this logarithm over and set them equal to each other. I'll go ahead and take a look at 25. 25 would be a little more interesting because it's a quadratic, as is 26. So let's take a look at 25. So basically, if you have log equal to log and it's the two terms, those inputs have to equal each other. Essentially, those have to be equal. So essentially, 25 is simply just the following equation. I just have to set those equal to each other. Take a moment, look at the equation, and then look at the original. It's just one-to-one property of logarithms. Go ahead and solve this. So I'm going to get all my p's on one side, so I'll subtract that 2p squared over, and I'll add that 24 over. Since it's a quadratic, I'm going to go ahead and set it to 0. So I'm moving that over and that over. And then I want two numbers that multiply to 24 and add up to 10. 6 and 4 will do the trick. So p equals -6, or p equals -4. All right. And there's our two solutions. Now, let me see here. Got to be careful that when you plug them in, you don't get a negative inside the logarithm. Look at my logarithmic equation. If I plug it in, I need to make sure I get a positive number. So let me plug in, say, -6. So I got 3 times -6 squared plus 10 times -6. I'm just plugging it into that logarithm there. I get a positive number, which is good, so that's fine. Now let me plug in the -6 over here on the right. So that's going to be -24 plus 2 times the quantity -6 squared, which is 48, which is good. Now let me plug in the -4. And I get 8, which is a positive number, so it's good. And if it's good on the left, it'll be good on the right. So we are good to go. So those 4 questions are very similar. Flipping on over, let's go ahead and look at these 4. So these 4 are all very similar. Notice there's an extra third term, so I can't set the logarithms equal to each other. So what that means is I'm going to have to switch them to an exponential. We'll have to combine them first. So we'll take a look at 27. So remember, subtraction of logarithms translates into division. And notice we can't set the log equal to a log because we got an extra term floating around. So it's not going to be as easy as the last 4. But we can combine these two. Just like that. Remember, subtraction translates into a division property. And switch it to an exponential. Now, you had to do this on your last test, switching between them. So a base 7 logarithm can be switched to a base 7 exponential. Just remember, logarithms and exponentials are inverse functions, so these input and output are going to get reversed. The old output will become the new input, and the old input will become the new output. So when you switch it to an exponential, these two things are going to get swapped around on opposite sides of the equal sign. And a base 7 logarithm switch to a base 7 exponential. And 7 to the first power is just 7, so multiply by 8, which will give us 63. I'm sorry, 56. And then just subtract. And there's our answer. I'll also go ahead and take a look at 29. So there's 29. So again, we got a third non-logarithmic term, so we're going to have to combine logarithms and switch to an exponential. Remember, addition translates into multiplication. So that'll translate into x times x plus 4. And now we're ready to go ahead and switch it. All right. So go and switch it to an exponential. So base 5 logarithm can be switched to base 5 exponential. And remember, these are going to get flipped around. And now it's business as usual. 5 to the first power will just be 5. Notice here I can go ahead and distribute. So it'll give me x squared plus 4x. Notice that gives me a quadratic, so we'll set it to 0. Get everything on one side. Subtracting the 5 over, and then we'll go ahead and factor it. So plus 5 minus 1, we'll factor it. X equals negative 5, or x equals 1. Now if I look at the original equation, remember you cannot have negatives inside the logarithm. So if I go to check my answer, if I plug this negative 5 back into the original equation, I will get negative inside the logarithm, which is no good. That's extraneous. So 1 is the only answer that works. If I plug 1 back in, it'll say positive inside the logarithm. All right. And then 28 and 30 are both going to be very, very similar to 27 and 29. Which brings us to the last 3 questions, which are all pretty similar. So this is, we're going to be using that compound interest formula from class. I'll go ahead and write it here. So that's amount or balance equals P times 1 plus R over N raised to NT. So there's that compound interest formula we're going to be using. We'll go ahead and look at part A. So if you go ahead and look at part A, it asks in what year will the balance reach $20,000. So we're going to set, remember A stands for the balance. We're going to set the balance equal to $20,000. If you read the problem, it says Helen invested $8,000. That's the principal. All right. And then the interest rate is 6.1%, so 0.061. And it's compounding monthly, so that's 12 times per year. All right. So what I'm going to go ahead and do is I'm going to have to use logarithms, but first I want to isolate the exponential, so I'll divide both sides by 8,000 for starters. And cancel out that multiplication. So we got 20,000 divided by 8,000, which is going to be 2.5. And I'm going to go ahead and clean up this base. So got 1 plus 0.061 divided by 12. So I'm going to go and punch that in. So I'm going to round that to 4 decimal places, so that's going to be 1.0051, roughly. 0.0051 raised to the 12t. And now, to solve exponential equations, this equation is no different than what we did in problem, 19, 20, 21, 22. It's no different than those. Go ahead and log both sides. The reason we log both sides is that lets us pull the power out front. So I can pull that power out from orbit. And then once we got it pulled out of orbit, all we got to do is divide. So divide both sides by the multiplication you don't want. And then we can let the calculator do the rest from there, right? Because that cancels that. That'll get t by itself. So we'll see what t is approximately. So if I type that in, that's going to be natural log 2.5 divided by the quantity. Remember to keep your denominator in parentheses of 12 times natural log of 1.0051. That's roughly 15.01, roughly speaking. So that means read the problem here. That was invested in 2019, and it's going to take 15 years, a little over 15 years. So in what year? Well, let's go ahead and add that. So 2019 plus the 15.01. So that means in the year 2034 is when it will reach $20,000, sometime in that year is the answer to that question. And then part B is going to be a little more straightforward. So we need to figure out what the time value is and how much will the investment be worth once you graduate in 2023. Well, it was invested in 2019. So to go from 2019 to 2023, you can do some subtraction if you want. It's going to be 4 years. So that means t equals 4. So notice nothing needs to be solved here. You just plug in 4 into the equation. So that's 8,000 is the principal. 6.1% interest. Monthly is 12. And punch in 4 for t. So notice here, we don't need to solve for anything. We can just punch that into the calculator. And there we have it, 10,204. And 45 cents. There we have it. 32 and 33 are both going to be very, very similar questions. So that's that. So go ahead and finish up this test review. Remember, your test will be Tuesday of next week, and then Friday we will be having a quiz over this material. So go ahead and spend the rest of the class period finishing up this review, and have a nice day.